This is only on, if you're just tuning in, you haven't missed much, the same side of the equal sign. Someone is excited about math. I love it.
No.
So you cannot reach across the equal sign to gather things even if they might be like. The equal sign functions as a wall. You cannot cross it. You know what? That will be someone else's problem. Isolate. So step 2 is to isolate the variable by moving, using addition or subtraction, things to the other side. And then lastly, we're going to isolate the variable by multiplying or dividing. Now, if you notice, this is exactly the opposite order of what? Thank you, Juno. This is exactly the opposite of BEDMAS. Chapter 1, I gave you guys expressions that were going to solve these things. There was fractions, there was decimals, there was all sorts of brackets in places. And we said, okay, we're going to solve this thing using BEDMAS. That was true while we were doing math where we knew everything. All of the values were present. And we worked left to right. Now, when we're isolating for a variable is exactly the opposite. What we're doing down here is functionally, if we're adding and subtracting things away first, and then multiplying or dividing things away, effectively what we're doing is SAMDEB. The opposite of BEDMAS. Okay? And I'll show you what I mean by that. Another way to think of this is you want to get rid of the terms that don't include your variable, and then you want to isolate that last term for that variable. I will show you what I mean. Here we go. Simple example is this. I've got 5x plus 3 equals 23. We have multiple terms here now, and so this is going to require multiple steps. So, do I have like terms on the same side of the equal sign? Marcus says no. Marcus is correct. So because I have no like terms here, there's nothing to group. I jump straight to my next step. I'm going to start working backwards. I'm going to deal with any of the subtraction or addition. Then I'm going to deal with any of the multiplication or division. Then I'm going to deal with any exponents or brackets that are present. So I have 5x plus 3 equals 23. I want to isolate the term with my variable. So I want to get rid of this plus 3. Jackson, what do I do? We are not subtracting 5. We're adding 3. So to undo the adding of the 3, we're going to subtract the 3. And to keep things fair, whatever we do to one side, we have to do to the other. So when my plus 3 and minus 3 interact, they're going to add together, give us 0. 5x plus 0 is just going to be 5x. And on the right-hand side, we're going to have 23 minus 3, which is 20. Cool. Now I've gotten rid of every term that doesn't include x. So let's isolate for x in the term that remains. When there is no math operation written, the assumption is that what's happening between the 5 and the x? We're multiplying. So to undo that, we divide. Thank you. And we divide by what we're multiplying by. Instead of multiplying by 5, we're going to divide by 5. Don't divide by the variable. That puts it in the denominator on the other side. That's bad. We're going to divide by the coefficient. 5 divided by 5 is 1, leaving us just with x. And 20 divided by 5 is 4. Now I demonstrated this yesterday. I'm going to demonstrate this again. The beauty of algebra is that it has a built-in check mechanism. To check whether or not you've done a question properly, assuming I haven't given you an answer key, you can take your value and plug it back in. So I've got 5x plus 3 equals 23. What I'm going to do is I'm going to take the value we think x might be and shove it back into the equation. I'm going to replace my variable with a set of brackets. So we're going to get 5 bracket bracket plus 3 equals 23. And I'm going to take this 4 and I'm going to shove it in there. And now we're going to bedmass this sucker. 5 times 4 is 20. 20 plus 3 is that equal to 23? 20 plus 3 is not equal to 23? Wow, Emma, you're brutal. Or was that Brielle? One of the two of you is brutal. Yes, this is a true statement. At the risk of you guys screwing around last block on a Friday, Gershon B. So this then must be correct. If it produces a true statement, that is the correct answer. Okay, let's do another one. This guy here. I got -2 plus x over 3 equals -4. Do I have any like terms there on the same side of the equal sign? Gino says no. Gino's correct. So what am I going to try and get rid of first? That -2. How do I get rid of a -2? We're going to add 2. Very good. Because it's -2 plus x over 3, I want to get rid of that -2. So we're going to add 2 to both sides. -2 plus 2 is 0. Cancels away. It's gone. Leaving us with 0 plus x over 3, which is just x over 3. On the right-hand side, we've got -4 plus 2, which is -4 plus 2. -2. Thank you, Caitlin. And now I've got x over 3 equals -2. When I have things written as a fraction is just division. Sweet. So to undo this division, what am I going to do? Thank you, Brielle. And we're going to multiply by what we're dividing by. So the reason we multiply here is because it's going to cancel with what's down there. Boom, gone. Leaves us with 1x. And then -2 times 3 is? -6. We can check it. Let's plug it back in. I'm going to check by writing out my original equation and replacing my variable with what we think the answer could be. Now we're going to solve this thing using BEDMAS. BEDMAS says I do what first? Yes. Is there math to do inside the brackets? No. There's no exponents. Division's next. What's -6 over 3? -2. So I'm going to have -2 plus -2. Is that equal to -4? You bet it is. So because this is a true statement, this must be correct. Love it. As always, please stop me if I've left you behind or if you're confused about something. Okay, here we go. Next, yes, still Quran. Oh, you're stretching, it's not a question. Here we go. The only difference between this question and the question that came before it is what? What's new about this one? We have 3 terms, and 2 of them happen to be? More specifically? Negative is less useful. What's useful about, or why am I doing this question? Sorry? Because it's assigned. No. There's a reason why I picked the examples that I picked. Dilkaran. No. Jackson. No. Sorry, someone said it. Juno. Yeah, this one is the first one with like terms. So, let's examine the question for those of you who didn't notice. I've got x over -2 minus 7 plus 2 equals 6. The first step I told you guys about was if there are like terms, we want to collect them. Oh, look, there's like terms. Which ones are they? Thank you, Gershon. -7 and +2. So our first step is to group those. What is -7 plus 2? -5. So this is going to become x over negative 2 minus 5 equals 6. And that's it. We've gathered all of the like terms on the same side of the equal sign. So now we can go ahead and solve this thing. We want to get rid of any terms that don't have variables. So what am I doing? We're going to get rid of the negative 5. To get rid of this negative 5, someone said it over here already, we have to add 5. Thank you, Jackson. And whatever we do to one side, we have to do to the other. Negative 5 plus 5 cancels. The only thing we have left on the left-hand side is x over negative 2. And that's going to, sorry, Aiden? It is going to equal 11. You bet. Now I've got x over negative 2, which is, fractions are just division. X divided by negative 2. To get x by itself, we're going to multiply by what? Not 2. Negative 2. We don't want negative x. We want x alone. We want it positive. So we're going to multiply by negative 2 to get rid of this divided by negative 2. And whatever we do to one side, we have to do to the other. These are going to cancel, leaving us with x equals what? Thank you, Gershon. Thank you, Jackson. Negative 22. I'm going to skip the check on this one, if that's okay with you. Comments, questions, concerns on anything we've done here? Okay, I got 2 more for you. You got the hang of it? I like to hear that. That's good. Okay, next one. Here we go. The only difference between this one and the last one is there's more like terms. Yeah. It would be boring if you were like, yeah, I got it, and then it never got any harder.
It would not get boring if you thought it.
You do know it. That's good that you know it. So we're just going to add another piece in here. Here we go. The only difference here, Jackson, is now there's 2 sets of like terms. Jackson, I want you to take a look at the screen, and I want you to tell me what the like terms are. Negative 4 and negative 2, you betcha. Someone else, what is the other set of like terms here? Yes, Juno. Negative 3x and positive x. So I've got 2 sets of like terms here. So let's combine those 2 sets of like terms. What is negative 3x plus x? It's going to, no, we're adding and subtracting here. So the exponents aren't changing. We're not multiplying or dividing variables. We're just adding them together. Negative 3x's plus 1x is negative 2x. That guy's done. That guy's done. And then negative 4 minus 2, negative 6 equals 5. Nothing's happened on the right-hand side. So now, I want to get x by itself. Let's remove any terms that don't include the x. That term is the negative 6 here. To move this minus 6 over, we are going to add 6, you betcha. Instead of subtracting 6 to cancel it out, let's add 6 to both sides. So on the left-hand side, we're just going to be left with negative 2x equals 11 again. And now I want to get x by itself. How are the negative 2 and the x attached to each other? They are multiplied. So to undo that, we have to divide. And we're not dividing by 2, not dividing by x, negative 2. I believe that you believe you knew that, but you got to be real careful not to drop those minus signs. Negative 2 divided by negative 2 is 1, leaving us with just x. And over here, we're going to get 11 over negative 2. Is this a reducible fraction? Is this a reducible fraction? No. If it's not a reducible fraction, you can totally acceptably leave this as 11 over negative 2. Gershon, you just said that you could also leave it as what? You could leave it as negative 5.5, you betcha. If, like Oliver, you have a compulsion to leave things as decimals. Or, as Gershon asked earlier, you can leave this as a mixed number. This would be negative 5.5. Any of these three is acceptable. It would be in your best interest to get comfortable leaving things like this. Okay. One more. I want you guys to slide over this question, and I want you to scribble it out. No, we didn't do it. Because it's the fourth one is the same as the third one. Oh, no, the fourth one is the same as the fifth one. And so I skipped this guy. It's exactly the same as the one down here. So in the interest of time and giving you guys more to practice with, I skipped it. And we're going to scribble this guy out. And we're going to change the question. I want to give you a more useful one. The question I'm going to give you is this. N minus 8 all over 4 equals negative 2. Yeah. So, this is one that is different than what we've seen before. All of the other ones, the other two that involved fractions, guys, the second or the third one only had x over whatever. The second one had x over 3. The third one had x over negative 2. This one has a whole binomial in the numerator all over to the denominator. No, you may not use the washroom until I'm done. Sorry? Oh, okay. What's your question? I don't know, because I want to switch it up. Okay, so, Sahib and Dilkaran, there are, Hayden's, two ways to attempt a question like this. I'm going to show you two different techniques. Raven, you just got to pick one that you are satisfied with of these two techniques. I don't care which one you choose. I'm going to show you two ways to do it. Here we go. We're going to go there, and we're going to go here. Two different techniques. The first is this. In the last chapter on polynomials, when I gave you an expression like this, what did we do? I gave you a binomial or a trinomial, and I had it over some monomial denominator. Gershon, what did we do? We would, yes, we would split the numerator up into each piece and divide each term by the denominator. So that's the first possible technique. I'm going to rewrite this as n over 4 minus 8 over 4 equals negative 2. When you've got a polynomial, in this case a binomial, in the numerator, one technique is to solve it like this. And now we just simplify each piece. Sam and Dilkaran. Can I do anything with this n over 4? No. Can I do anything with this 8 over 4? Yeah, 8 over 4 is? No. You're so close. It's 2. So this is going to become n over 4 minus 2 equals negative 2. Okay. Don't worry about it, Raven. Raven. Up here. Okay. Now I want to get n by itself. Hayden. Stop. Don't just leave the things that are on his desk alone. Don't add anything to Hayden's desk. You don't remember, some of you guys are going to want to go to LSS or to ABET. You don't get to go unless you finish this. So, what am I going to do here to get rid of, what am I going to get rid of first here on this left-hand side? We're going to get rid of any term that doesn't include a variable. So we're going to get rid of this negative 2. To get rid of this negative 2, what do? We add 2. Because we're subtracting by 2, the opposite operation of subtraction by 2 is addition by 2. Negative 2 plus 2 is 0, leaving us just with n over 4. And negative 2 plus 2 is 0, leaving us with n over 4 equals 0. So now to get n by itself, we're going to multiply both sides by 4. N 4 divided by 4 is 1, leaving us just with n. So 0 times 4 is 0. So n is 0. Let's check to see if that's true. If I plug 0 in here, 0 minus 8 is -8. -8 divided by -8 divided by +4 is -2. So we're good. Okay, that is one technique for solving this problem. I will show you the other. Instead of doing it this way, if you would like a slightly shorter method, what you can do is recognize that when I've got something in the numerator, the entire numerator counts as a single object. And what we're going to do to make that painfully clear, Hayden, is we're going to throw a set of brackets around it. So what I'm going to do is I'm going to rewrite this as n minus 8 in brackets over 4 equals -2. Now, if you look at what I wrote down up at the top, when I tried to demonstrate that this is just reverse BEDMAS, what is the very last thing we deal with in the isolation reverse BEDMAS? The brackets are the very last thing we can deal with. So let's deal with them last. The first thing I'm going to get rid of is this division by 4. Right, so I can times by 4 on both sides. When I multiply this side by 4, it's going to cancel with the division by 4. You don't distribute it in, you cancel it with what's in the denominator, leaving us just with n minus 8. When it's the only thing there, we can now drop the brackets. And on the right-hand side, we're going to have -2 times 4, which is -8. And now I've only got one step left here. The last step to get n by itself is then to do what? Yeah, we're going to add 8. If I have n minus 8 and I want to get n by itself, we're going to add 8 to both sides, and -8 plus 8 is 0. So I'm left with n plus 0, which is just n. And then on the right-hand side, -8 plus 8 is 0, which is the same result we had before, which is good. If you're doing the same question 2 different ways, you sure as heck better get the same answer or you screwed up somewhere. I don't care which way you choose to approach a question with a binomial numerator. You just need to pick a technique, get comfortable with it, and then that's what you should then use. Questions? Yes? No? Here's what I want you to do. I'm going to assign the following. That's it. Those are my examples. I'm going to assign you a chunk of homework. Here it is. I want you to do questions numbers 1 to 30 odds. So that's half the questions. And I want you to do question number 16. And then I want you to flip ahead a couple pages. And we're going to skip the books who were never written. And we're going to jump straight ahead to why did Gonzo walk around carrying ice cream and a pair of birds? Pair of sparrows, sorry. This page is homework as well. As always, the evens are optional, and this books that were never written is optional extra practice. Questions 1 to 30, 16, and this page are your guys' homework. You have 30-ish minutes. 25 minutes? Yeah, there's a whole line of people who want to go to the bathroom first. Dilkaran asked first. He can go to the bathroom. And Jackson may go. And when either one of those get back, then Liam, then you. Wow. We all have to go pee this badly? Okay, here's the list. Did you take down all of my examples?
Yes.
Okay, hold on. We've got, who did I just let go? Why are you taking your stuff?
I was asking if I could.
Yes. You know what? You guys actually get stuff done down there?
Yes.
Okay, fine. The 2 of you go. Okay, so my bathroom order. Dill, Karan, Now those two are going to the indigenous swim, so they don't count anymore. So, yeah. When either one of these two get back, Gershon wanted to go. And Brielle wanted to go. Who else is Caitlin? Yeah, Jeffy, you can go. You can go. Two of you. You and Dokron are going. When you get back, then Gershon, B, and Brielle get to go. Okay, you have a task. Get to work.
And then I go after.
Okay, the rest of you have your task. Any emergency different.
Ow.
That's the end of the block.
Why you touch my face?